educate me about calibration here.
The main body of the cartridge is one solid piece from the tail end to the nose. This is a piece of exotic high chromium tool steel. We actually worked with the metallurgist who invented this steel. It's a very wear resistant, extremely stable tool steel invented for die making. Unlike any of the steel that's traditionally used in machines, we actually worked with the metallurgist to come up with a heat treatment process, a triple tempering and cryogenic treatment to produce the most stable, wear-resistant condition of this steel. But this sleeve is grounded within 50 millions. It's like a cylindrical gauge. You put this cylindrical gauge into your machine's collet closer, and then you actually apply the clamping load of the collet closer, because the toggle fingers, the cam in the back, the tension on the bearings in the subspindle or the main spindle, as you tighten that, it stretches and bends everything in the subspindle slightly. It affects the runout. Let's say if your spindle nose cap has a problem, or if the toggle fingers are really worn, maybe they're unevenly applying force on different sides of the sleeve, it can actually degrade your concentricity. By measuring our cartridge nose, you're actually measuring how the spindle is performing under load, under clamping load. There's no other way to really do that without a precision cylindrical mandrel as our cartridge is. So it can really save time troubleshooting. When you get our cartridge to run true in your machine, every collet, every job's going to run true. It solves the problem right up front. You don't have to do trial and error and goof around. We have an extensive 2-page troubleshooting flowchart of how to troubleshoot concentricity using the microconic cartridge. Once you invest that time to get that thing to run true, your concentricity problems are eliminated.
There's less expansion in the morning, less subject to temperature changes.
With the micrograd dial setting and clamping force, it's entirely controlled inside our cartridge. It's regardless of what the machine does. So as your machine warms up, the machine's adjustment's back here, the part is out here. So as that spindle grows and shrinks, with temperature as the machine warms up, it can affect your clamping force. But with our system, first thing in the morning or the end of the shift by Friday after it's been running 24/7, it's all the same, because it's all entirely controlled inside of our cartridge, where thermal expansion is essentially canceled out inside the cartridge. So clamping force is extremely stable.